Good afternoon. My name is DSigler. I'm a student at Grantham University. This is the presentation of my capstone project for my Bachelor's of Science in Electronic Engineering Technology. I've been working with a local homeowners association to develop a snow removal plan. One of the tasks for this plan is to determine the most cost-effective, reliable means of communicating in the cold weather between the main snowplow and the individual ground teams. A suggestion was made to determine whether building receivers in-house for the ground teams would be less expensive and as reliable as a commercially purchased radio. The purpose of this project is to investigate this suggestion and make a recommendation to the Homeowners Association Board. Our objectives were straightforward. We were to determine the cost and availability of commercial radios from local stores such as Walmart or Meijer. We were to determine a simple and cost-effective receiver design to construct in-house. Once we built and tested the receiver, we were to acquire all the associated cost information and all the reliability test data. Then we were to make a recommendation of which way to proceed to the Homeowners Association Board. Communication is an important part of any infrastructure. A team of workers spread out over a neighborhood in several square miles with no line of sight need to know where to be at any given time. Since this homeowners association does not have an abundance of money, they asked us to determine the most reliable and reasonably priced means of communication available. When selecting a reliable design for this receiver, we had to have cost versus reliability weighing in. Also, the availability of the components were an important part. Just as important, we needed to have the proper test equipment for design and testing phases. In this design, we needed a signal generator, an oscilloscope, and a signal analyzer. However, not having much money, the Homeowners Association chose to not provide the test equipment for the testing. The initial schedule, which was laid out in January, was followed very closely, and we made all milestones completed on time. Assembling all the components for the breadboard build and testing took 2 days longer than initially planned. However, this time was built into the schedule, so we did not miss the milestone. We selected a simple transistor receiver using an inductive capacitive oscillator. As noted, the problem with that was the oscillations were not sustainable in this design. We could have improved this design drastically by using the crystal oscillator and possibly op-amp circuits. Theory of operation for this radio is fairly simple. The FM signal is received by the antenna across the inductor L1 and applied to the emitter of Q1 through coupling capacitor C3. The FM signal is then passed through Q1, emitter to collector, and through C4 and applied to the junction of R8, R6. Sensitivity of the FM signal is developed across R1, R6 by adjusting R1 for the best signal. The FM signal is mixed with the oscillator output at the junction of C4R8, and the resulting signal is applied to the audio detector consisting of a low-pass filter of R8C7 and applied to the base of Q2. The audio signal is then applied through C8 to the audio amplifier stage consisting of Q3, Q4, and the associated circuitry. And the output is supplied to the earphone jack through coupling capacitor C1. As noted, we did not have the test equipment to properly run signals through this receiver. So there were 2 points that we were able to do. We measured all the nodes for the transistors. The following slides show the various transistors. In the simulation, we run an injected signal into the base of Q2 and monitored at the output with the oscilloscope. In our circuit, we weren't capable of doing that. So what we did was we injected a signal into the base of Q2 and listened to it on the earphone output. This is the breadboard in Multisim, which depicts the circuit that we were using for analyzing in Multisim. This is the actual breadboard in use that we have here. Our final recommendation to the board was to purchase a commercially available radio. The cost variance is negligible. However, the reliability of the in-house radio is suspect. We were not able to sustain oscillations with the circuit, so the receiver sporadically received anything. We could have improved the reliability of this receiver by changing the architecture to op-amp circuits and a crystal oscillator circuit. And we could have invested the money in test equipment. However, the Homeowners Association did not have that available. So the final recommendation is for them to purchase a commercially available radio. And this concludes my presentation of my capstone project. Thank you very much.